Hey guys, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at lesson 1 from chapter 5, which is talking about radicals. And more specifically in this video, we're going to look at ordering radicals. And so to order radicals, you first have to convert all of them into entire radical form. And then from there, all you have to do is order them. So if you guys remember from the lesson, to convert to entire radical form, your radical should essentially have all the numbers inside of your radical symbol. So say we had 4 times the square root of 2. You'd want to bring this number inside. And so in order to do that, you have to take the exponent of whatever this index is. And in this case, when nothing there is, you're going to assume that it is an exponent of 2. So essentially what this will look like is 4 squared, so it gets that index, and then times the number that was inside that radical. So we get 4 squared, which is 16, times 2, which is 32. So this here is entire radical form. This here is what we call mixed form. So you can kind of think of it almost like a mixed number and an improper fraction. So there's one where we have the whole number out front, and then the other form we have everything inside of that radical. One little note here, just remember to keep in mind that any negative numbers are actually smaller if their digits themselves are large. So say, for example, we had -2 and -32. Well, 32 itself is a big number, but because it has that negative symbol, it actually makes it smaller than -2. So same sort of idea here. Say we had the negative square root of 2 and the negative square root of 32. Same idea. This number inside that square root symbol might look pretty big, but because it's a negative symbol, it's going to be smaller than the square root of 2. Same thing, you can even double check that. Put it into your calculators and you guys will get a decimal number, and you would find that once again square root of 2 might be negative 1 point something number, whereas the square root of 32 might be negative 5 point something. Okay, so although they look bigger, they're actually technically smaller numbers because of that negative symbol right out in front there. So what we're going to do is we're going to do an example from your notes, and this one here is the very last example. So here what we're going to do is we're going to determine which radical is the largest. And so in order to do that, we're going to first convert them into entire radical form, and then we can order them to figure out which one is the largest. So here we have 8 times the square root of 3. Our other number is 4 times 13 to the power of 1/2. And we have 14, and then the square root of 202. So what we're going to do is we're going to take each number and turn it into an entire radical form. So I'm going to deal with 8 square root of 3 first. So what I want to do is, in order to turn that into entire radical form, I need to bring this 8 inside of your square root symbol. And in order to do that, it needs to get an exponent of whatever that index is. And like I said earlier, if nothing's there, you're going to assume that it's a 2. So you're going to write your square root symbol, then you write the number that was right out front, and then write it with that exponent of whatever that index was, and then multiply by the number inside that radical. If we want to take it step by step, we can go 8 squared is 64. And then we can multiply 64 and 3, and we should get 192. Then we can look at 4 times this 13 to the power of 1/2. One thing that's really important here is that we can rewrite this exponent here. Whenever you have a fraction, that would indicate that you have some sort of radical. So what you're going to do is you're going to write 4 outside, and this 1/2 only applies to the 13. So you're going to write your radical symbol, and whatever number is in the denominator of fraction becomes your index. And because our index here is 2, we don't actually have to write anything. All we have to do is write this 13 inside. So remember, if there's nothing here, you assume it's a 2. Then what we can do is we can bring this 4 inside of that square root symbol. So we're going to write square root. We're going to write 4 to the exponent of that index, which is 2, times the number inside the radical. 4 squared can be simplified to 16. And then multiply it with 13. And if we were to put that into our calculator, so go 16 times 13, we should get 208 in our calculator. Then we can look at our third number here. So here we have just 14. Now you might ask yourself, well, we can't really do anything with this number here. There's no square root with it. There's nothing. But one thing that we have to do is in order to compare these numbers, we need to write it using the same radical. So if this is the square root of 92, square root of 208, then we need to rewrite 14 as a square root. So you could assume that this is, say, you can even write square root of 1 right beside it if it makes your brain happier, because square root of 1 is just 1, and that actually doesn't change this. It's like writing a number over 1. It writes it as it looks like a fraction, although it really doesn't change your number. But that way it helps you to see how you can change this into an entire radical form. So we're going to bring that 14 inside. And so here we have that index of 2, so we're going to have 14 squared times 1. And 14 squared is 196 times 1, which is just 196. So then our answer there is square root of 196. And if you guys didn't want to write this step here, the square root of 1, you don't have to. It just, for some people, might make their brain happier just to see the square root beside the number. But really all you have to do is write the number with the square root and that exponent, and then just simplify by expanding. Then our fourth number here, we have the square root of 202. If you guys notice, there's no numbers outside of that square root, so this here is already in entire radical form, so we don't actually have to do anything with that. So now to determine which radical is the largest, we just have to look at which one has the largest number inside the radicand. So here we have 192. Here we have 208, we have 196, and 202. These here are all positive values, so we don't actually have to worry about being confused about any negatives. So really here, all we have to do is look at that number that's the biggest inside that radicand. And here, you guys haven't noticed yet, your biggest number here is 208. So that means that 4 times 13 to the power of 1/2 is the largest radical. So then we can write, therefore, and make sure whenever you're answering these questions, use the original number that was given. So we're going to say, therefore, 4 times 13 to the power of 1/2 is the largest radical. So that is everything for this video. So if you guys have any questions, just make sure to come see me in class or text me on Remind 101. And thank you guys so much for watching.